Hello everybody. Okay, this might be a fun project if anybody has a CB radio that they would like to put on the ham bands. Any ham band, well, the one we won't worry about is 2 meters. That gets real technical. But basically any of the lower frequency ham bands, any CB radio, be it AM, sideband, or even FM. This little device right here will do it. The device itself is called a transverter. I didn't invent it, but the idea had been around for a long time, and there's quite a story behind this that involves some friends of mine that were being bothered by some jammers on CB while I ran a CB shop, a TV repair shop, and this went on quite a while. And they would get extra channels, and they'd run to that channel and talk for a while until the jammers would figure out where they went, and then they'd get bothered. So that went along for quite a while, and the time that I happened by a table at the ham swap meet in Puyallup, and I picked up a ARRL handbook, and it showed a schematic in there for a 2-meter transverter that would put a 28 megahertz 10-meter radio on the 2-meter band, and it was tube type. So that got me to thinking about if it could go up in frequency, why would it be, or how hard would it be to make it go down in frequency? In other words, convert down convert. So what I came up with is a circuit that puts in 27 megs. It subtracts 20 megahertz from that and comes out on 7 for this particular unit. So, in other words, channel 1, 26965, would come out at 6.965 megahertz. So, if you had sideband or AM on the radio, you could dial up into one of the ham bands. The 40, actually, that would be the 40-meter band. So, I built a couple of these and got them all hooked up, set their antennas up. The device uses an external 40-meter antenna that's activated when the device is put in from standby to operate. It has a key-in circuit just like a linear amplifier. It hooks directly to a CB. There's no modifications that we ever had to do to the CBs. You just hook it up, choose the channel, and whenever you get bothered, our little code word that we would use is we would just say, take it to Star Trek. And those poor idiots on the CB band that were trying to jam us, they were hunting around and hunting. They thought we were up around triple nickel or something. They got their radios modified and VFOs, and they thought we were hiding between channels, and they never did find us. Well, they had no clue where we were so far away from them that there's just no way that they could ever done it. This circuit I have here in front of me uses one tube for an RF amp. It has RF gain control. There's a little peaking control that allows you to bring up the receive sensitivity. And on key up, it takes a sample of the 27 megahertz radio into a dummy load, samples a little bit of that, runs it into a mixer. The local oscillator runs at 20 megahertz. The mixer takes that 20 megahertz, extracts 20 megahertz from the 27 megahertz signal, goes through a 12BY7 preamp for the finals, and this tube was a voltage regulator to keep the oscillator stable. The outputs on here are a pair of two E26s. This unit would put out about 35-40 watts with a pair of two E26s. Good, really good power. And I'm going to build another version of this. And these tubes are really cheap. They're 42KN6. They're like a 6KD6 with a 42 volt filament. And a pair of these will do about 100-150 watts. So that makes a real decent little ham radio if you wanted to go right into one of the ham bands, where you could use your sideband CB radio and put it on one of the on 40 meters. What varies is the local oscillator crystal. You would change that if you wanted to, say, go to 80 meters or 75 meters, or 20 or 15 or 10 meters. Well, 10 meters you wouldn't need, because most CB's radios will do 10 meters. This is more concerned with somewhere between the 40 meter band, 80 meter band, or the 20 meter band. The full circuit transmit and receive, here it is, looks like that. That's power supply, the RF amp, the mixer oscillator, the oscillator, local oscillator, a transmit mixer, transmit driver, and two finals. And this, just the receive portion, this is what it looks like. This is what's used in just the receive portion. The camera's picking that up or not. Here you can see the RF amp, the mixer, local oscillator. That's the only part of it. I mean, you could use just that, and you could actually receive the ham bands on your CB radio if you wanted to build a tube type, old school rig type thing. Okay, this is what it uses for the transmit side. Uses the oscillator again, transmit mixer, the 12BY7 driver, and a pair of finals. The voltage for this thing isn't too hard to come up with. These tubes used 400 volts for the two E26s. When I rebuild this and into a bigger unit, I'll probably use 800 or 900 volts for the 42KN6, so they can put out good power. Filament voltage, I use 24 volt relays, so you'd need 24 volts. About 30 volts of negative bias for the output tubes, and the rest of this operates on like 250 volts. The voltage regulator regulates at 150 volts, and that runs the oscillator and the mixers, so that if you use sideband, your carrier voice wouldn't distort or change frequencies. So what I'm asking is, if there's any interest in this kind of a project, I'd like to hear feedback. Anybody interested to build this, if I get enough interest, I'll do a series of videos that will step by step build one of these rigs up. So let me hear from you, your thoughts, what you might want to use for tubes, output tubes. The rest, all these tubes are cheap. These 42KN6s are like $5, maybe $8 on eBay. It's because it's just an odd filament voltage, but it's essentially the same as a 6LF6, 6KD6, 6KN6, which is its exact cousin, and this is only a 42 volt filament. Easy to come by. The other tubes are a 6AU6, a 6U8 for the mixer oscillator, a 12BY7, and the transmit mixer is a 6CS6. It's probably the only odd one in there. It's an equivalent to a 12BE6 or a 6BE6. But the circuit that I come up with this, or found part of that circuit, that CS6, that came out of a transmitter that was actually using that for a transmit mixer. And that's why I chose it over choosing or using a 6BE6 for my converter. Okay, let me hear your feedback, what your thoughts. Like I say, let me know if you think this would be a fun project, if you'd like to make something using vacuum tubes. Okay, thank you for watching. Hope to hear from you. Bye.